Hello all, welcome to this video on the roadmap of computer networks. So in this video, we will understand what, why and how about the computer networks. But before we deep dive into the computer networks, I would like to introduce myself. My name is Laksh and I graduated in the year 2014 and I did my BE in Electronics and Communication from Sri Krishna College of Technology, Coimbatore. I currently work in a company called Cisco, which is one of the top companies in the networking industry. And I have 8.5 years of experience. And in these 8.5 years of experience, I was mainly working in the technology of routing and switching. So in this short roadmap video of computer networks, you will understand what is routing and switching also. You can connect with me on LinkedIn and search my name as Lakshmikant PS, and we can connect over LinkedIn. So in this short video, we will understand what computer networks is, why was there a need to create computer networks, and how computer networks work. So let's get on with it. Now let us use a real-time example. So here in this diagram, you can see that there are two users. So just consider a user as your friend. Basically, this user is a friend of yours, and the other is user is you. So you are using Facebook application on your phone, and your friend is using the web browser on his laptop, and he is running Facebook. So it looks very simple to you, right? Meaning that your phone is connected to your Wi-Fi router in your home, and then your friend's laptop is connected to his Wi-Fi router, and then you both are talking to each other. It looks very simple, right? Similarly, anything that you do in the real world, like web browsing, meaning you are working or you are checking something on Google, you're watching a movie on Netflix, or you're watching some sports event on Hotstar. Okay, it looks very simple. All you have to do is open your mobile phone or your laptop or your smart TV, open the application, and you start viewing it. It's very simple, right? But between this simple network that you are so using it so much, where everything looks very easy and you are able to enjoy your daily dose of happiness, etc., there is something which connects you to the internet. That internet belongs in this part of the tick mark. And this internet is not a simple thing. But if we understand computer networks, this complex internet becomes very easy to understand. So internet might not look as simple as just a tick mark here, but the internet would look something like this. So this picture actually gives a very simplistic imagination or visualization of how internet looks like. So you would have already heard in your school days or in your subjects that there is something called as World Wide Web, which we commonly denote as WWW. And that WWW is usually denoted in the form of a globe, correct? So similarly, in this diagram, if you see, you can see there are multiple laptops, there are multiple mobile phones, there are multiple users basically who are connected across multiple other users in the world. And that interconnection, right? That interconnection of these multiple users, multiple devices is done through internet. So internet basically means that it is the intercommunication intercommunication of networks. That is the meaning of internet. Intercommunication of networks. So the full form of internet is intercommunication of networks. So first we'll have to understand why was there a need of intercommunication of networks. Even before going on to the intercommunication of networks, we have to understand what is networks. Okay. So take an example that you are sitting in your home, right? And you have multiple devices in your home. You have laptops, you have mobile phones, you have a smart TV. If you have a smart fridge, that is also connected to internet, right? You would have heard of something called as IoTs, etc. So you have multiple networking devices. Okay, so I will start to write networks using two letters, that is N slash W. This means networks. Okay, so you have multiple networking devices. So what are networking devices? First of all, any device that can connect to the internet is a networking device. So your laptop, your mobile phone, your smart TV, all these are networking devices. So in your home, you have many networking devices, and all these networking devices are talking to each other, right? So you have formed a small network. You have formed a small network in your home with multiple networking devices, right? So this is an example of networks. Now, you are not only talking to devices inside your home, but you are also talking to devices outside your home, right? So there is something called as an outside network, right? Where these devices in the outside network are completely different from the devices in your home, right? But then you are able to talk to these networks, right? So this is an example of a small network, right? Now you are able to talk to the network outside your home. How is that possible, right? That is possible because your home network is connected. That is what I said. It is connected outside. It is connected out to the outside network, and it is communicating, and hence it is called as intercommunication of networks. Okay, so second thing, we understood what are networks. Now why did the need come up that different networks should be communicated? So earlier, when a computational devices or a computer was invented, basically a computer was invented with the role or with the expectation that it can do maths, it can do maths or mathematical calculations faster than human beings. That is why it was invented. Then, as technology developed, a need came up that two computers, I am drawing a computer in the form of a PC here. So a need came up where two computers have to be connected so that they can share each other some information, right? So this itself formed a small network. A network is created so that each devices can share some or the other information with each other. That is why the need came up of creating networks. Now, The third point is how are they connected? This is where the knowledge of computer networks come. So these networks are connected using wires, right? That is cables. Then they are connected wirelessly, wireless like air, right? Your Wi-Fi is a wireless connection. Your satellite connection, your mobile data network, you talk to someone over phone, that is all wireless communication, right? So networks are connected either through a wired network or a wireless network. So in this computer networks subject, we will be learning only about wired technology, not about wireless. Wireless technology is a completely different set of technology, which is a different subject altogether. So I hope all of you are with me till now. So moving on, learning the computer networks, okay, with real time scenario. What is a real time scenario? Okay, let me write that down. Real time, meaning whatever is going on around you in reality is called as real time. So computer networks is very easy to understand. It's a very complex subject. As you go deeper and deeper into the computer network subject, it's a complex subject because it is internet. Internet is a connection of different networks, and that connection might be complex, but understanding that complexity is easy if you compare it with real time situations in the world. Okay, so for example, you are looking into this video, okay, through an app. Okay, so all you need to understand is how your phone or your laptop is able to contact the server over which this app is running, right? If you understand that, you will understand internet. So my request with you people is that whenever you are learning computer networks, always compare it with real time scenarios, and I have done my best to explain computer networks using real time. So let's move on further. As you all know that when you design something, when you invent something, when you develop something, or you do anything, this whole world is running based on some rules and regulations. Without rules and regulations, the world cannot run, right? There will be lot of chaos. For example, in your city, okay, you are standing on a junction, okay, and this junction has four roads interconnecting. So just imagine that if for some reason on this junction the traffic signals stops working. When this traffic signal stops working, no one follows the traffic rules. When no one follows traffic rules, there is a traffic jam, right? And no one can pass through, right? So there are vehicles, there are buses, there are cars, there are scooters, cyclists, etc. All of them trying to go from one end to the other end, right? But then since there is no traffic regulations being followed, there is a traffic jam. Similarly, in a networking environment, in computer networks, you have similar junctions. Okay, that junction is basically called as either router or a switch. We will learn about these two devices later. So routers and switches are two kinds of devices that act as junctions where multiple wires, multiple wires or cables are connected, and they help in transferring your data. Okay, so just imagine that if these routers or switches do not follow any rule, what can happen? In real time world, cars, buses, trains, all your transportation vehicles are way less than the traffic that is in the internet. Internet has huge amount of traffic, and with traffic, internet traffic, I mean data, okay, or information. So there is a lot of data or information going on inside the internet. Okay, if all these data do not follow some traffic rules, there will be a complete mess. There will be complete chaos. So in order for these routers or switches and the traffic to be followed in a sequential manner or in a proper manner, we came up with OSI or TCP IP model. Using OSI or TCP IP model, any networking device can talk to any other networking device inside a network or outside a network. So basically, OSI stands for Open Standard Interconnect. Open standard interconnect, meaning that it is an open standard, as you can see already see that, and it's an open standard for interconnection of devices. Okay, that is one type of model. The next model is called as TCP IP model. So TCP stands for Transfer Control Protocol. Control Protocol. And IP stands for Internet Protocol. So using these two models, any networking device can talk to some other networking device. If they do not follow the rules inside these models, you will not be, or your networking device will not be able to talk to any other networking device. That's the first and foremost criteria. So here I have a diagram of the OSI model. Okay, and in this diagram you can see that there are multiple layers, and believe me, these layers are inside your networking device. Now you're watching this video on your phone or on your laptop or a tab or anywhere using some kind of networking device. Okay, that networking device will have all these layers inside it. Okay, so the OSI model is present in all the networking devices no matter what. That's the first and foremost rule. Now, these layers are responsible for carrying your information or your data in some or the other method. Right? So you can see here that there are 7 layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Okay, so if you just simply look into the picture, you may have a small visualization or understanding of what these different layers might do. Okay, I'm not saying that you will understand it fully, but I will try to give you small details of what these different layers do. Okay, now once you understand computer networks, or in future when you become a network engineer, okay, like me, if you become, or if you choose to become a network engineer, you will be mostly working on these 3 layers: data link layer, network layer, and the transport layer. Our majority of the work will be on these three layers. The physical layer here, if you see the physical layer, people like field engineers. Okay, in networking world, we call them as field engineers. Okay, what is the work of a field engineer? You would have seen a technician coming into your home, connecting your Wi-Fi modem and giving you an internet connectivity. He is one type of field engineers. Similarly, you have field engineers who work on your telephone towers. Okay, they work on your telephone towers. So they their work is to connect or is to work on the cables that are inside your telecom tower and connect them to their respective ports. We will come across ports and other stuffs later. So they are also one type of field engineers. Okay, so mostly the field engineers work on the layer one. Network engineers, we work on data link layer, network layer, and the transport layer. These layers I will go a bit deeper in the later point of the video. Now, all your developers, software developers, okay, your coders, your C++, your Java, or whatever software you want, all of those, they work on these three layers: session layer, presentation layer, and application layer. Okay, so if you are interested in coding, you would be working on these three layers. Okay, if you are working as a network engineer, you would be mostly working on these three layers. But trust me, if you choose to become a network engineer and also learn coding, right, you are on top of your field, because in today's world, a software engineer alone a software engineer alone cannot be cannot be given the responsibility of owning everything. You will understand this later. What I mean to say is that if you know how two devices talk to each other, okay, that is incomplete. That is still incomplete. But if you also know these three layers, the layers, session layer, presentation layer, and application layer, that which is the work of a software engineer, your skill set your skill set for the market or for the industries is very very high. So the starting salary that you might get is extremely high, trust me. So if you are really interested, start learning networks, start learning coding right away, so that you know both these skill sets, so that your future is very very bright. Now coming back to the layers, what I'm going to do is I will be diving a bit deeper into each of these layers one by one. One more thing I wanted to tell you guys was this diagram that you see is of OSI layer model. There is another model called as TCP layer, TCP IP model. The only difference between OSI and the TCP model is that these three layers are integrated into one and called as application layer. So instead of having 7 layers, TCP IP model has only 5 layers. Okay, the first 4 layers, that is physical layer, data link layer, network layer, and transport layer, remains the same in TCP IP model. The last 3 layers are called as the application layer in TCP IP model. That is the only difference in OSI and TCP IP model. So getting a bit deeper here, let's move on to the very first layer, that is the physical layer. So as you can see here that physical layer means to work with basically with the cables. Okay. And without cables, you know that none of the network devices can talk. Right now, everything works based on cables, right? Your laptop is being charged through a cable, right? Your charger has a cable. Your Wi-Fi modem is connected through a cable, right? Your telephone, landline telephone is connected through a cable. So the cabling or the physical layer knowledge is also very important in understanding computer networks. So here you can see that there are different types of cables, and you would have already seen all these cables in your real life, right? So here you can see this is a DVI cable, right? This is an HDMI cable. You might not have seen this cable, but this is a fiber optics cable. This is a high end fiber optics cable. Okay, this is an Ethernet cable. This is an Cat 5e cable. This is a USB cable. You can see this is a C-type cable, right? So there are different types of cable, right? And you know that without cables, our devices cannot run. Okay, so in the physical layer, you will be understanding how these cables work, what are the different types of bandwidth. I used a term called bandwidth. Bandwidth basically means, in a very simple term, speed. The speed of each cable. Speed here means the transferring of data. At what speed that the cable can transfer information. So you would have heard something called as kbps, right? Mbps or gbps. Okay, kilobytes per second, megabytes per second, gigabytes per second. Okay, so these are different types of speeds, and all these cables usually have different types of bandwidth or speed. So you would be understanding these information or this knowledge in the physical layer. So in real time, if you enter an office or if you enter your computer lab, you would see that your computer has an Ethernet cable, okay, and that is connected to a socket on the wall. That might look something like this. Okay, so this cable here would be connected to your computer in the lab, right? Next, if you see here, this cable is a Cat 5e cable. Cat 5e cable has a different speed. You can also see here is a telephone cable, and also you can see here is a TV cable with which you get the cables to your TV. So with this diagram, you can also understand how important cabling is. Without cables, you cannot have connectivity to different devices. Now, you may also ask, there are wireless connectivity also. Yes, right now I am talking only about wired connectivity. There are different types of wired medium, but there is only one type of wireless medium, that is air, right? So air is the only wireless medium. But I'm not talking about wireless technology here. I'm talking about wired technology. So moving on, this was about physical layer, that is layer 1. Now what we will do is we will understand the next layer, which is called as layer 2 or the data link layer.